In this tutorial, we are going to discuss how to compute the area and perimeter of shapes using coordinate geometry and at the same time integrating the fundamentals of algebraic methods. Alright, so take a look at this diagram or this example that we have been given. We need to compute the area and perimeter of this triangle. Okay. Now keep in mind that in this triangle we have not been provided with any dimensions or any angles, right? All we have been given is the location of three vertices of this triangle, right? So let's say my vertex P has a coordinate of -2, 0 as you see here, right? And you have a vertex Q, it has coordinate -1 and 2, and then you have vertex R, it has coordinates 1 and 1, right? Now, based on these three vertices, we can compute the side lengths of this triangle, right? So let's say we compute that this is my side length A and this is side length B and you have side length C. So let's first try to measure that what are the actual distances of each one of those side length, okay? And using the distance formula in coordinate geometry, I can say that A is equal to the difference of x coordinates of these two vertices P and Q. So that will be -1 minus -2 and whole square of that plus the difference of y coordinates, which will be 2 minus 0 square of that, and this whole thing comes under a square root, right? And this will be a square root of 5, correct? It will be equal to 2.23. And using the same principle, you can compute the side length B, and it will be once again the difference of x coordinates between P and R, that will be -2 minus 1 and whole square of that plus 0 minus 1 and square of that, right? And that once you solve this mathematics, you'll find that this is equal to square root of 10, right? So it will be 3 square plus 1 square, right? And then you have the side length C, which is the distance from Q to R. It will be using the same principle. It will be -1 minus 1 square of that plus 2 minus 1 and square of that, and that will be square root of 5. So let's solve these radicals and then say that square root of 10 is equal to 3.16, square root of 5 is equal to 2.23. We already have it here, right? So based on this, now you have three side lengths. What will be the perimeter? Perimeter will be simply a sum of all three dimensions that you have obtained so far, right? And that will be equal to 7.62. Now we don't know what these units are, so let's say that we are assigning some units to this XY coordinate system. Let's say this is in centimeter. So in that case, you will say that the perimeter is 7.62 centimeter. All right, we got it so far. Now we have one of the answer in this question, right? We need to still calculate the area, right? Now in this case, you can say that there are multiple ways to calculate the area. One possible way is that we can assign one of these side as the base and then we compute the height from the opposite vertex to that base and then we compute this dimension, right? Now you see that to be able to compute this height, you need that point where this perpendicular will intersect with the base, right? And we don't have that point with us, right? So it might be a little bit complicated to compute the area using the standard formula of a triangle, which is 1/2 times the base times the height. So rather what we do is we can use a different approach. What we can do is we can compute the area of this triangle using Heron's formula. That area of any triangle can be computed as a product of these four measurements, which is S times S minus A times S minus B times S minus C and square root of that, right? Now you will ask that what are these four values, the S, the A and the B and the C. A, B and C are the three dimensions of the triangle that we have under consideration, right? And the value S is defined as the half of the perimeter, right? We already know what this value is, 7.62. So you can easily compute the value of S. That becomes 7.62 divided by 2 and it is 3.81. So now you have all the four values that you need to be able to compute this area using the Heron's formula, right? So all I'm going to do is that I'm going to substitute these four values in this formula, that these are my values here. So area would be equal to 2.48 centimeter square. Okay. Now, what is the key point that you want to take home from this exercise? The key point is that using the coordinate geometry, we can easily compute what are the distances of the required shape that we have under consideration. And using those distances and using some standard formulas, we can easily compute the area or perimeter of that required shape, right? Now let's take a look at one more example in which we are going to utilize a slightly different approach to calculate the area. Okay, so let's go take a look at that. All right, so in this case, we have this shape that we are supposed to calculate the area of this quadrilateral QRST that has four vertices as given to us. Okay, now you look at this diagram and tell me that does it look like a trapezium? Yes, it does. So we can say that the area in this case can be computed as 1/2 times B1 plus B2 times H. In this case, the B1 and B2 are the two sides that are parallel to each other, and H would be the perpendicular distance between these two parallel sides. Okay. Now, since we have been provided with these four vertices, it is easy to calculate the length B1 and the length B2, right? But we don't have the coordinates of this height, that is the distance between these two parallel lines. So it might be a little bit challenging to compute the height. So in that case, instead of taking this approach, that this standard formula for computing the area of this trapezium, I would rather take a different approach. My approach would be to say that, can I compute the area of each one of those squares that are included in this trapezium? I think I could. So if I look at only this square, I see that based on this XY coordinate system that we have, we can tell that the dimensions of this square are 1 and 1 unit each, right? So in that case, if this is my area 1, I would say that the area 1 would be equal to 1 times 1, or it will be 1. Let's say this is in centimeter square. I'm assuming that the dimensions of X and Y coordinates are in centimeter. Likewise, you will say that there is another square that is completely enclosed in this shape. So let's say that is my area 2. All right. So that will be identical to this. So it will be also 1 centimeter square. What else you see here that is unique in this diagram? I see that if I take this triangle, this is exactly the half of this square, right? So this is one triangle. So let's say this is my area number 3, okay? And the area of this would be 1/2 times base times height, because base is 1 unit long and height is also 1 unit long, right? It is easy to compute that way. So this will be 1/2 centimeter square. And likewise, I can find that there are 3 more triangles that are identical to triangle number 3. So this is triangle number 4 we are talking about here. This is triangle number 5 we are talking about. This is triangle number 6. So you can say with ease that there is triangle 4 that has area, triangle 5, triangle 6. All of them will be identical because they are precisely 1/2 of this square, right? So that will be 1/2 times 1 times 1, and that will be 1/2 centimeter square. So what will be the total area in this case? The total area will be simply a summation of all of those 6 individual areas that we have computed, correct? If I were to rewrite this, the total area will be A1 plus A2 plus A3 plus A4, A5, A6, and that is equal to 1 plus 1 plus 4 times 1/2. I am taking this 1/2 from here, and there are 4 of those. Or in nutshell, you will say with ease that this total area is equal to 4 centimeters square, right? So you see that we did not have to compute the area of this trapezium using the standard formula. We could simply employ the principles of coordinate geometry, and we could compute the individual block area to calculate this total area, right? Well, this was another point, that how do you calculate the area of the shapes, right? We can utilize variety of methods. The ultimate objective is to keep it simple. Utilize any of those principles, whether it's a Pythagorean theorem, whether it is a combination of individual elements, or whether it is utilization of Heron's principles. The idea is utilize all the fundamentals that you know and compute the area and perimeter with ease. Okay.